Hello, in this video, I'm going to be showing you another case of supervised learning, which is classification. Unlike regression, where we use the model when we want to predict a value or a number, in classification, we want to predict which group something belongs to. For example, is this email a spam or not a spam? Is this image a cat or a dog? Does this patient have diabetes or not. To do that, we are going to use a technique called logistic regression. Please don't let the word regression fool you just because this has the word regression in it. That does not mean we are trying to predict a number like what we did with linear regression. No, logistic regression is used for classification, but logistic regression works kind of similar to linear regression in the beginning. It still uses the same basic idea, same basic math, which if you still, hopefully you still remember it, we used like y hat equals to w, which were all the weights, dot x, which were all the input features, plus a bias. So it first creates a raw score using all those weights and biases. So it figures out all the weights and biases. So it is kind of doing the regression, but it does not stop there. After that, it uses other math function to turn those raw scores into probability scores. And finally, based on the probability scores, it chooses one category over the other one, which is going to be the final answer, final prediction for us. We already talked about the math behind these in previous videos, so if you haven't watched those yet, please go ahead and watch those first. In this video, I just want to demonstrate how we can implement these different type of logistic regression, which are like binary classification and multi-class classifications using a scikit-learn and write a code for it and everything. So here we are starting with a binary classification. Binary classification, basically we are picking from two models. It's either this or that. With the multi-class classification, now we have a lot of groups, a lot of classes that we need to pick from. So I am going to, so this is basically where I import all the classes and everything. And I'm going to be using the data, which basically has all the information about diabetes, like whether or not this is going to be the outcome, whether if it's zero, that means you don't have diabetes. If it's one, that means you do. So it looks at your pregnancies, insulin level, BMI, things like that, and it wants to predict whether or not this person has diabetes. So the first thing I do, I just look at the data a little bit, and same as a linear regression, we just separate all the input features with all the targets and or labels. So I just put all the input features in this variable x binary and all the targets in this variable y binary. And then I just looked at them, and keep that in mind, this is still supervised learning. So we have all the answers and everything. And same as linear regression, we want to split the data into training and testing. And I just do the same thing that I did for linear regression. So I picked 20% for testing data and 80% for training data. So this is going to be my input features for training, and these are the targets that match these input features, and 20% for testing, and these are the targets that match these 20% data for training. And I just called the logistic regression function here, which we already imported at the top from the scikit-learn. And as you can see, I'm repeating this 1,000 times. Why do we need to repeat this? Because probably if we just run the system once or twice, it cannot generate proper weights and biases for this. So we're gonna repeat it. And we gotta be careful how many times we are repeating this. If you just go too low, probably you're not giving it enough opportunity to come up with good weights and biases. If you just go too high, you're just wasting time. But for data small like this, probably 1,000 times is more than enough. And then you wanna train your data. You just call the fit method. Again, same as linear regression. You just give it your input features and all the targets, and that's it. It's done. So what it does, it generates all those weights and biases for our model, and then you give it your test data and it predicts things. So since this is a binary classification, this function logistic regression kind of understand it, and behind the scene it's going to use those raw scores, and it's going to use sigmoid function to generate kind of like probability scores for each case. And then it picks one of those probability scores. Well, this is a binary classification, so that means we're going to end up with two cases. So it's going to generate a probability scores for each case, and then it's going to pick one of them as a result. And we can look at the score here. You can call the score method on your model, or you can call this function. As you can see, both of them are saying the same thing. So that means it can generate or predict the right category 75% of the time. And we can also look at the confusion matrix. It's actually easy. So depends on what row and column we are looking at. So this is row 0, column 0, which means the right answer was 0, and in 78 cases, our model was able to generate 0. So this is row 0, column 1, which means in 21 cases, the right answer was 0, but our model generated 1. This is row 1, column 0. That means in 18 cases, the right answer was 1, but our model generated 0. And this is row 1, column 1, which means in 37 cases, our model, the right answer was 1, and our model was able to generate, predict 1. So this, if you look at it, look at this diagonal. So these are the right answers, basically. The right answer was 0. 78 cases, it was able to predict 0. In 37 cases, the right answer was 1, and the model was able to predict 1. And we can also generate like a classification report. Just to keep the video short, I'm not going to go over this one because even if I go over it, it's going to be confusing. So I'm just letting you to just read all these parts. It's clear, everything I already explained everything clearly. So please just read it, see what type of information this report is providing. And we can also look at the probabilities. These probability scores were generated by sigmoid function, right? And the way we pick the right answer, right classification from these probability scores is that in binary classification, there's a threshold, which is 0.5. If one of these probability scores is equal or greater than 0.5, that's going to be the answer. So in this case, 0 is going to be the final prediction. In this case, 1 is going to be the final prediction because this is greater than 0.5. Very easy, very straightforward. That's it. You just call the functions that you already have. You just predict something. I guess here, same thing we did with the linear regression. I just generated some random results, and just to demonstrate how you can use your model to predict a single value. That's the goal for this part, because basically this is not a real data, so it's going to generate something. But I just wanted to show you, okay, now you have a single data, you want to use your model to predict something. So here it is. So it's going to predict it. We can also look at the probability. So this our model thinks this person does not have diabetes, and look at that. So the first case was greater than 0.5. So that's why the final prediction was class 0. Very simple, very straightforward. So for multi-class classification, everything is going to be the same. The only difference is that now we need to pick from more than 2 classes. And the only difference here is that our system still generates raw scores and then generates probability scores, but this time it does not use sigmoid function, it uses softmax function, which again we explained in previous videos. And then from all those probability scores, it's just going to pick the one that has the maximum probability score. That's going to be the class. That's going to be the final class prediction that we have. So I use this data for this, which basically predicts what type of flower species we are dealing with based on the sepal length, sepal width, petal length, and petal width. But same process, exactly same process. So we divide our data into training and testing. We call the logistic regression function again. Logistic regression function can understand whether or not we are dealing with the binary classification or multi-class classification, which is nice. We are repeating it 1,000 times, which in this case probably is more than enough. And then we just give it our testing cases, and look what we are getting here. The accuracy now is 100%, which is great. And if we look at the confusion matrix, do you see this diagonal results? So that means the result was 0. We predicted 0. The result was 1. The correct answer was 1, and our model predicted class 1, and this means the right class was 2, and our model was able to predict 2, class 2. By the way, we have 3 types of classes here. Yeah, we have 3 types of classes, 3 types of different like flowers that we need to pick from. These are our targets, different targets that we have. So this is not definitely binary. This is not 2. We have more than 2 different classes to pick from. Again, it kind of uses the same process, but instead of using sigmoid, it uses softmax to generate probability scores, and the class with the highest probability is going to be the final answer. So we can look at the probabilities. So for example, here, this one has a maximum probability, so this is going to be class 1. This one has the maximum probability. This one is going to be class 0. Just simple as that. It's very simple, very straightforward. Again, I'm just generating some random numbers here to just predict what type of class we're dealing with. And this is going to be the setosa flower, as you can see. So please go through all these practices. The code is extremely simple and straightforward and intuitive. But here there are different type of data provided for you. Just import them, divide them into training and test, train your model, look at your score, try to predict something with it, use your testing data to test your model, and look at the scores and everything. So there are practices for binary classification. There's also practice for multi-class classification with a different type of data. So please go through all these practices. I'm sure after doing this, you're going to feel a lot better about all these coding and everything.